page 9. Section 2, we are going to transition from point estimates to interval estimates. Section 1, what we just did like 10 minutes ago, was all point estimate. I take a sample, I find a single estimate of a population parameter. So if I'm estimating mu, I find x bar. If I'm estimating pi, I find p. The issue with that is that samples change. So if I take one sample, my estimate of mu is going to be different than if I take a second sample, because sample means are probably going to change. So that's why we do confidence intervals. So in section 2, we're going to do confidence interval for proportion. So what is a confidence interval? Write this down. It's an interval estimate of a population parameter. In other words, it gives a range of plausible values for a population parameter. So a confidence interval gives a range of plausible values for a population parameter. Okay, a confidence level is reported as a percent between 0 and 100. Most of the time it's going to be 80% or above. And it specifically speaks to your confidence in the process. That's very important. A confidence level has to do with your confidence in your process. It has nothing to do with the specific interval that you found. So you're going to find a 90% confidence interval. The 90% has nothing to do with the interval itself, but instead with the process that brought you to that interval. So we're going to interpret it later, so I'm just going to leave that for right now. Okay, so the process for a confidence interval is called panic. So you need to write this down. It's for a confidence interval. Any time at all for the rest of the semester that I tell you to calculate a confidence interval, I mean do panic. Okay, P stands for parameter. So you are defining your parameter. You're saying let mu equal, let pi equal, let sigma equal. We're only going to do mu and pi, but this section we're only doing pi. So pi is what we're trying to estimate. So let pi be the population proportion of people with brown hair. So what we're trying to estimate. A stands for the assumptions. There's always going to be 2 or 3 assumptions that you need to check. All of those assumptions need to be true in order to carry out the rest of the confidence interval. N stands for name. Under this category, you need to tell me the confidence interval name. You need to tell me what table you are using to calculate that confidence interval. And then you need to tell me the confidence level. A lot of times it'll tell you calculate a 90% confidence interval, calculate an 80% confidence interval. That's what the confidence level means. If I don't tell you a percentage, you use 95%. So the default is 95 if I don't tell you, but like majority of the time I'll tell you. I is for the interval itself. So I is where you first do calculations. You're not going to do any calculations for the interval in P, A, or N. I is when you actually do the calculations. C is your conclusion. For your conclusion, you need 2 interpretations. First thing that you are going to interpret is your interval. Second thing that you are going to interpret is the confidence level. So if I calculate a 90% confidence interval, what does the 90% mean? Do you guys understand what I mean by interval? Yeah. That you're going to have an estimate and a margin of error. So you're going to end up with something like, I think the population proportion of people with brown hair is between 0.5 and 0.6. This is the answer that you're going to end up with. Okay. Bless you.
Is it usually a closed interval or open interval?
It's closed. It doesn't matter, but yeah, it's closed. Okay. Are you guys ready to just like jump in? Okay, awesome. I'm thinking we should just do a complete confidence interval, like a whole panic. You ready for that? Together. Yeah. No, together. You guys don't know how to do it yet. Yeah, together. Go to page 12. At the top of page 12 is a confidence interval problem, so we're going to do this together. Okay. You are a polling consultant to a member of Congress. A simple random sample of 500 voters finds 28% have environmental problems as the most important issue. Give a 90% confidence interval and explain the results to the congressman. Okay. So what they tell us is that 28% of these voters have environmental problems as the most important issue. That comes from a sample. That's a proportion. That's P. That's your sample proportion. So what we're going to estimate is the population proportion of people who have environmental problems as the most important issue. So that's our P. In this section, it's always going to be proportion. So we're estimating proportion, we're estimating pi. So we're going to say let pi be the population proportion of voters with environmental problems as the most important issue. So that is the P. Next, we have to check the assumptions. The first assumption for every single panic, every single phantoms, every problem for the entire rest of the semester is going to be the same assumption. That assumption is that you have a random sample. Remember that you can only generalize from a sample to the population if the sample is random. Here it says simple random sample. So I just want you to write yes, stated. Second assumption, you need to check if you have a large sample. Checking if you have a large sample is really checking if the sampling distribution is approximately normal. Do you guys remember how to check if the sampling distribution is approximately normal from chapter 8? You check n pi greater than or equal to 10. Here we don't have pi, so you're going to check np greater than or equal to 10 and n1 minus p greater than or equal to 10. And do you remember how I want you to check both? You can't just check one and then check it off.
Do we have five?
No, we have p.
At the top?
So n is 500. There were 500 voters. P is 0.28. 500 times 0.28 is 140, which is certainly greater than or equal to 10. N is still 500. Then we have 1 minus 0.28. This is 360, which is greater than or equal to 10. Okay, so I want you to say something like, yes, the sample is large enough. And tell me that you checked it. Third thing that you need to check is you need to make sure that your sample size is small relative to the population. So you need to check that N is less than 10% of big N. Big N being the population. Do you guys remember why we have to check that? It's always the same reason.
Replacement.
Yeah. So if this is true, sampling with and without replacement are the same, or fairly the same. And this whole process only works if you're sampling with replacement, which we never do, which is why you have to check this assumption. So our little n is 500. We don't know the population size, so I want you to solve for the population size. Our population has to be greater than 5,000. We don't know anything about these voters, who they are. So we're going to write assume the population of voters to be over 5,000 people. Okay. Now we're on to N. Bless you. Bless you. You need to tell me what kind of interval it is, what your confidence level is, and what table you are using. So I'm going to say I am constructing a 90%, so that's the confidence level part. I know it's 90% because it told me in the problem. A 90%, it's called a large sample confidence interval for population proportion. Of course, you're going to write it out. Using the T critical values table. Which you've never used yet. Okay, so this is the first half of the problem so far. We still have I and C. I don't want to start them in the last 5 minutes. So here's what I want you to do. I would like you to look back at page 3. Okay, I would like to show you what I'm giving you points for. So this problem is worth 18 points when it's completely finished. You get a point for using the correct symbol, so for using pi. You get a point for using the word population. You get a point for the context, so that would be point 3. Point 4 is did you check if it was random? Point 5, did you check that it was large? Did you say that? So did you say that it was large, and then did you actually check it? So you said, then you checked. The 7th point is the 10% rule. The 8th point is the confidence level, so that 90%. The 9th point is this name. 10th point is for the table. And then you're going to get 8 more points for the rest of the problem. Anytime it's a confidence interval, it's always the T critical values table. Okay, do we have any questions on what we've done so far? Okay, we will finish this tomorrow.